Have you ever wondered how massive applications, the ones with billions of records, manage all that data without just grinding to a halt? Well, today we're going to pull back the curtain on an invisible engine inside SQL that makes it all work. It's a clever trick that solves a surprisingly common and honestly pretty destructive problem. So let's start with a puzzle. Imagine you're in charge of a database and you have to delete millions, maybe even hundreds of millions of old records. Now here's the catch. You have to do it on a live system, one that people are using right now. How do you pull that off without causing a complete and total meltdown? That's the real challenge we're going to tackle here. And here's the villain of our story, the dreaded table lock. See, when you try to run a gigantic delete operation, the database often just decides to lock the entire table to be safe. And that means nobody else can read from it, write to it, they can't do anything. For your users, the application is basically frozen solid. Now, this isn't just some theoretical thing. It is a real-world headache that database teams fight with all the time. And it has some major consequences for businesses and, of course, for their users. Okay, so let's break it down. The traditional way of deleting data is, frankly, a nightmare. It is a super slow physical operation that eats up resources. It causes this thing called lock escalation, which is what freezes the table. Your users are totally locked out while this is happening, and the only real solution is to schedule downtime, in the middle of the night, which is just a huge pain for everyone involved. But what if there was a better way? What if you could organize the data so that getting rid of a huge chunk of it was as simple as pulling one drawer out of a filing cabinet? Well, that's exactly what we're about to get into. And the hero of our story is a feature called table partitioning. It's a really simple but absolutely brilliant idea. Instead of keeping all your data in one giant, messy table, you just divide it into smaller, more manageable pieces. You can think of them as individual buckets or drawers. To really get this, let's use that filing cabinet analogy. Without partitioning, your database table is like one single enormous filing cabinet drawer. Everything's just tossed in there. If you want to remove all the files from, say, 2011, you have to dig through the entire drawer, making a huge mess and stopping anyone else from using it. But with partitioning, you get this beautiful after picture, a neatly organized cabinet. You've got a separate drawer for 2011, another one for 2012, and so on. Now, if you want to get rid of that 2011 data, you don't have to rifle through the whole cabinet. You just deal with that one single drawer. So how do you actually remove that drawer without shaking the whole cabinet? Well, that brings us to our first technique. And honestly, it feels a little bit like magic. It's a command called switch. The process is pretty straightforward. First, you just target the partition you want to get rid of, our 2011 drawer. Then you create a brand new empty table to hold that old data. You run the switch command and bam, instantly, all the data from that partition moves into your new archive table and it just vanishes from the main one. Now, what's so incredible here is why it's so fast. See, the switch command isn't physically moving all those gigabytes of data around. Like the quote says, it's a metadata change. The best way to think about it is this. Instead of moving an entire building, you're just changing the street sign out front. It's an administrative change, not a physical one. And the result? An operation that would have taken hours and locked down the whole system now completes in less than 1 second. No table locks, no user downtime, no staying up late for a maintenance window. It is a total game changer. Okay, so the switch command is amazing, but back in 2016, an even simpler method came along for when you just want the old data gone. So let's look at technique number 2. This one's called truncate partition. So let's compare them. Switch, you remember, needs a separate archive table. The big upside there is that it basically creates a backup for you. Truncate is way simpler, no extra table needed, but, and this is a big one, it permanently deletes the data. No backup. It's just gone. So really, it all comes down to a trade-off. Truncate is cleaner, faster to write, but you have to be 100% sure you will never need that data again. Because once you run it, there is no going back. Look, this might all seem super technical, but the ideas behind it have a huge impact on the digital services we all use every single day. At the end of the day, table partitioning is one of those invisible engines that just keeps our digital world running. It means way less downtime for users, it lets engineers do their maintenance work quickly and safely, and by keeping the main tables lean and organized, it makes the whole application feel faster and more responsive. It's the secret sauce that keeps the services we rely on running smoothly. And that really just leaves us with one final thought. we've just looked at one really clever piece of engineering that helps manage these oceans of data. But as we generate more and more information than ever before, you gotta wonder, what other invisible engines, what other clever structures are working behind the scenes, silently keeping our digital world from collapsing under its own weight?